Okay, I need to get some of these here bench anchors here for my workbench in my wood shop. I like how these look, how they work, and I think I like to make myself some. Use their design here of how they make this clamp in the bench really nice, and I'll get myself some of these here made now since I have my own hobby machine tools I can use, and I'll start making my own here now, and that's what's coming up next. Okay, the hole in my workbench, those holes are 5/8 inch diameter. And I have a piece of axle here, steel axle, that's about 590. So what I want is I want to have this bar has to be smaller by a certain amount than the hole it's going into so that they can slide past each other, the two pieces. So if I make this, keep that as at 590, so I'm going to go ahead and make two pieces out of this, and we'll get working on the bar here. Okay, for starters, I'm going to use a 3/8 bolt for the threaded part up here. And I'll probably come down about a 1/2 inch there. I need to take a look at the tap I'm going to be using for this. And if I come down about there, roughly there, that should give me enough to tap into for about maybe there. And that's about, I'd say about a 1/2 inch. So I'd say about a 1/2 inch here for the threaded portion of this. And then I come down and I use a binding bolt to put the two pieces together. A socket head cap screw here, a 1024, that will come down past there and catch about right there, the bottom of it, right there. Okay. And that measures out to be about 1 inch. So 1 inch from here to here, and then if I come down another maybe 3/4 of an inch, so about 1 3/4 for the entire thing, or I might go maybe full 2 inches. I'll probably go a full 2 inches, and I'll cut off at 2 inches each piece, and I'll make two of them at 2 inches. Alright, there's the two pieces cut. And over to the lathe to get them cleaned up on the facing cuts first. Okay, that's the top of it. That's 3/4 inch down. And I'm going to be slicing that on an angle, 45-degree angle from that line down on my milling machine. In my tilting vise here, I have it locked in at 45 degrees on a tilt. There's my line here. I'm going to put the workpiece in here, and I'm going to square it up. Put the jaws here. And use my square here to get it lined up vertical here. And I'm going to put the line down so I can see it on the bottom. That reference line we made. Square this up. Tighten it in nice and tight. And that should do it for that part. Okay, this is the part that I'm working on now. I'm working on making that there's slit down through here that makes those two pieces slide past each other when the bolt gets tightened up to make it into a clamping situation. So what I got going on here now is I have my slitting saw here lined up to that there 3/4 inch mark we just made before on my tilting vise here, and I'll now cut that on that angle. together like that, and they'll slide past each other like this. Lock in position. Okay, and they fit up there nice like that. They don't tip over. So that means they're nicely cut. And the one side here was cut 3/4 of an inch down this way here to give enough depth that we can put a binding screw in here that will come down so far like this, and then we can also thread it for a bolt for utility. And the other side here is a little bit smaller. It's almost about half, but there you go, and that should okay. Now the next thing I want to do is to put the main piece here, the top piece, in my lathe, and start working, drilling to get this here in, and then doing the tapping and things for the utility bolt as well. And that's coming up next. Okay, the 1024 threaded shank is about 180 thousandths of an inch. So I want to make the clearance hole for this to go through about 50 thousandths more in that range. So I'll see what value that will come out to on the drill size. 15/64 bit for this. That gives me about 50-some thousandths clearance for a 1024 screw shank. And I'll poke this hole all the way through. So I want about 50 thousandths wiggle room here. Now the head of this screw is about 310. So I think what I'll do is I'll use a probably a 5/16 end mill to counterbore this here for this screw head to go in and seat. I'm going to counterbore this to about 650 thousandths of an inch. I have my dowel indicator set up here on the tailstock. Touching right there, 0. I'm using a 2-flute end mill, 5/16 diameter, 50 thousandths. Hundred thousandths. Coming up on 300. 300 thousandths. It's cut nice and smooth now, real smooth. 350. 400. A little more juice here. 450. 500. 550. 600. 620. 640. 650. And that's the counterbore. Let's see how far back it goes. Okay, good. Okay, one last thing to do now, and that is to do the drilling and a tapping now for the utility bolt that will go in there, which would be about 3/8/16 thread, and that's coming up next. The tap size for a 3/8/16 is 5/16 inch, so I can actually just use that same counter bore hole now to do the tapping also, and I'll tap that in to about maybe 600 thou, around there. Okay, the bolts in are nice and straight. That's all the machine needs to do on this one. Let's check it out now and see how that works. I do want to put a little bit of a chamfer here. Just clean that edge up a little bit. Okay, let's check it out with the other bolt here. Slides through there like that. All the way down. Plenty of room there. And we got a lot of nice wiggle room here as we need. So we should be good there. Alright, let's do the bottom part now. Okay, now when we come to the second one here to drill, we have to offset this using a 4-jaw chuck. We have to offset it by at least 50 thousandths because we have this here, the diameter of this is 50 thousandths, around 40 to 50 thousandths less than the 5/8 hole it's going to go into. So when it's being offset by about 50 thousandths, when it tightens up and slides this way, it'll give us around the 5/8 or so that we need to clamp inside that 5/8 hole. So I have to get my 4-jaw chuck now so I can adjust this over about 50 thousandths. Now I have it on my 4-jaw chuck and I have it zeroed in on the 4-jaw chuck. So now I need to move it over that 50 thousandths of an inch. And I have the angle cut is on this jaw right here. So I have to move the angle cut now over towards the back side here, offset at 50 thousandths in that direction. My filler gauge here, and I got that set for 51 thousandths. Now here's a jaw here that holds the angle right here, the angle cut. I gotta go this direction, so I have to loosen this jaw here and stick this in here and gauge that out at 51 thousandths. So I take this back this way here now, and then I just take the jaw here and just adjust it back until it's touching there now. So now I'm 50 right there. So now I'm 51 thousandths. So now I got to push this direction here, and I'll try to do this carefully on camera. Now I'm going to have to loosen this a little bit because it has to slide past there now a little bit. So I'll loosen this a little bit, let that slide past, and now I'll tighten this to the front here and start sliding it over until I'm hitting this jaw here, which I am right there. Now I'll tighten this jaw back up again. There we go, and snug, feels snug, and we're tight here too. Okay, snug here, and that should take care of it. Okay, get this drilled now. I'm going to be drilling and tapping for a 10/24 thread. And I should be about 50 thousandths off center to make all this work properly. Deep enough here so that I can get my tap to go inside farther so I can tap almost all the way through if I can, because a 1024 tap is kind of small, but if I drill in wide enough I can have enough room to get the tap inside and really catch a lot of thread on the other side of the workpiece. That should take care of it right there. Alright. Put it together now. 1024 bolt goes in there like that, and then slides in there like this on there. Catch that on there like that. Okay. As that tightens down and slides past each other there. Okay, let's go try it out in the workbench now. See how it catches. See out there in the wood shop. Before I try it in my workbench, I want to take off these sharp edges here so that it's not catching on the wood bench itself, the hole. I don't want that sharp edge there. Okay, it's nice and blunt there now. Do the same thing for this one here too. Just to break that edge, that's all I'm doing. Let's make it blunt. Okay, let's go out to the wood shop and check and see how it works out now in the workbench. Okay, I'm at my wood workshop now, and we'll give it a try and see how this works now. Okay, this slides into a hole like this. Tighten it up here. Put a bolt in. Okay, it's going to work. Pull apart on it. Okay. See how solid it is. Alright. That works good. Now take it out. Could you just loosen it up a little bit? Okay, there we go. So you can see how that works. It slides past as the bolt goes down tight. They begin to slide past each other, and that's the kind of design that they came up with. It's a very good design. Very good design they came up with. And I made my own here now, and I can make a couple more now and have these for my workbench. Okay, that's all for this here project. Thank you for watching. Have fun in the shop. Bye bye. And I need to make sure that I understand that this is not my design. This is not my design at all. This is a design that's already been done with the Veritas bench dog, they call it. It's their design. It's just I'm just using it for my projects here. I'm using their design for my projects. And I'll give credit to where credit belongs, and it belongs to them that designed this. They did a nice job, they did. Okay, that's all for this here project, like I said, and so have fun in the shop, and bye.